tutorial, I will be showing you how to make a player health bar as well as enemy health bars, and at the end I will make enemy AI. So in order to make a player health bar, first you need to create a new UI canvas. You double click on the canvas, you can see this, makes you in 2D view. And then in this canvas we will create a UI raw image, and inside the canvas as well we will make an empty game object. We will rename this to health bar. And then we will grab the raw image, rename this to HP, and parent it to the health bar, like so. Stretch it out. And then we will press on the health bar, go up to this little bit up here, click on this. This is how we can anchor our health bar to a specific point on the screen. So we will press this one to point it down to the bottom left. We will then hold down Alt and click right here to set its location. Now if we resize this, you can see it's kind of working, but not quite. So we're going to have to hold down Shift and click as well, just to make sure that this point is right there on the corner. And so now if we enlarge this, it changes the health bar. Now we are going to duplicate this and set its HP to be transparent, and the original HP to be, I'll just go with red for now. Make sure that, and rename this new one to blank bar, and put it above the original so that it is behind it, like so. So now as we change the scale of the main health bar, you can see empty space behind it, which is exactly what we want. So now you change the scale of the health bar and it changes how much health is being shown. Now all we need to do is make this correspond to the player's health, and to do that we will open up the player manager in Visual Studio. Now we need to define our health bar. Up here in the player manager, we will create a new public game object, name this health bar, and now we need a health value, public float health, and let's make a new void update function. Anything that runs in the update function will be called every single frame, because we're doing continuous updates. So we need to set our health bar scale corresponding to how much health we are. We need to set our health bar scale based on how much health our player has, whatever value this is set to. In order to do that, we can set health bar dot transform dot scale dot local scale to set its scale. Make sure this is equal to a new vector 3. It's the same way we did positions. And then 1, 1, 1. All ones, default scale. But we need to change the X. What do we change it to? We change it to health. But most of the time, a player's health is measured in almost like percentages. Like it starts off at 100, and half health is 50. A quarter health is 25. So instead, we're going to have this health value, because it's like 100, and then divide it by 100. So if your health is 100, then this value is going to end up being 1. 100 over 100 equals 1. So the scale is 1, which is the default, and if it's 50, then it's 50 over 100, which is going to calculate to 0.5, which will make it half the scale as it usually is, because the default is, once again, 1. So we're going to do health over 100. And assuming the health bar's default scale is 111, of course, which it should be if you did what I did just a second ago. So make sure the health bar is scaling based on what the health is. And now, we should be able to test this in Unity. The first and last steps we need is to assign the health bar, drag it into the player manager. Ignoring this blank bar, that doesn't matter. The health bar is the only thing we actually care about at the moment. That's the thing that needs to scale, and then make the default health 100. Now if we play the game, we should have a nice red bar on our screen, which is exactly what we want. And of course, the enemies don't actually damage us. Like in the last tutorial, all they do is restart the game, which isn't really what we want, but we can fix that. But for now, let's test our new health bar. If I decrease the health, health is 89, and that's what the health bar looks like. Decrease it some more until it goes smaller and smaller and smaller, and if health is 0, then this bar is empty. And if health is negative, then it goes backwards, but we don't talk about that. And if it's more than 100, then it goes above the health bar. But that's probably fine. Depending on your project, having health that goes above 100 go past the standard health bar may or may not be a good thing. I'm going to assume it is here because setting a main max health is very useful. But just in case, let's go back into our script and add some quick support for that, and then we'll go to the enemies and make sure that enemies actually deal damage. So now, the only thing we didn't account for is if your health goes over max health, or if you want your max health to be different, there's no way to do that. So to make it so that it is possible, because what if you want to have 500 health instead of 100? Then you can make a new public float max health, and then instead of dividing by 100, because 100 is the max, divide by the max health. Now, it should work perfectly. If your max health is 500 and your health is 500, then 500 over 500 is just going to be 1, so your health bar is going to be at its default scale. If it's 50 out of 500, then it's going to be really small, and if it's 250 out of 500, then it's going to be 1/2. It works perfectly. So now that that's done, there's one other issue to attend to. Enemies don't do damage. They don't deal health. They just restart the scene, because back when we coded that, there wasn't any health, but now there is health, so we need them to actually remove health instead. Unless you don't want that, but assuming you do, the way you do that is get rid of the restarting script and then make it so if you touch enemy, then set health equal to health minus 1. But wait, what if we want to make different enemies do different amounts of damage? Well, there's an easy way to do that too. Instead of minusing by 1, you can minus and then get a value like this. GameObject.getComponent enemy. So now we can get a value specifically from the enemy script pertaining to each enemy individually. And what is that value? We can get the damage value. Of course, there is no damage value connected to the enemy script, but we can make one. So let's go to enemy, and let's make a new script, or not a new script, sorry, a new float value, call it damage. And now, for every single enemy, we can assign them a specified damage value, which is how much damage they do whenever we touch them. And this should work pretty well. Let's go back into Unity and test it. Right before we test it, of course, we need to make sure max health is set to 100 or 500 or whatever we want it to be. And then let's give our enemies, or, well, our enemy, because there's only one enemy, as you can see. I'm gonna turn off... No, this is fine, actually. I'm gonna go to the enemy, and I'm going to set his damage to be, how about 10? That looks fine. Damage of 10. The max health is just 100, so 10 hits to kill should be fine. Now, if we start the game, if we touch an enemy, we get hurt. Let me restart the game real quick. That was a little strange. Let me try that again. If we touch the enemy, we get hurt. Okay, I see one problem here. This thing is too big. We need to make sure that this is, minimized, so we don't accidentally touch it. Because you're supposed to have to stomp on the enemy to kill them. That's the idea. So I'm just gonna quickly shrink up that box there, and we'll try that again. Now, if we touch the enemy, it shouldn't disappear, but it does do damage. Now, this is pretty good. The only problem is, if you can get into a cycle like this, where you should obviously be taking damage right now, but you're not. And that's kind of an issue. The second issue is once you reach 0 or go below 0, you don't die, nothing happens. And I'm going to fix that in just a moment, but you can still stomp the enemy as before, and that all works perfectly fine, but once again, there's no set timer. It's based on collision hits. So, if you just, stay next to an enemy the entire time, you won't collide with it any more than once. and you won't take any damage, which isn't really what we want. We want it to be a set timer. So let's go back into script and fix both of those problems. So very quickly, we can make it so the scene restarts once we reach 0 health by it's pretty simple. We just have a new if statement inside of our update function that checks if health comparison equals 0, or actually is less than or equal to 0 in case we go into the negatives. If it's less than or equal to 0, then set health equal to 0 and then restart the scene. So scene manager, because this works because we already defined what Unity scene management, Unity engine.scene management, we already defined that we're using this, so we don't have to type it in again. .load scene, scene manager.load scene. What scene do we want to load? Well, we can get an index number, build index. But what is this build index? Where are we getting it from? We're getting it from the current scene. Get active scene. So we're loading the scene. What scene are we loading? We're loading the active scene build index number, which will load the scene that we are in. If our health is less than or equal to 0, then it will set the health to 0, and then restart the scene. So that problem is immediately fixed. The only other problem here is the fact that, once again, if you stay on an enemy, you don't take damage. You take damage once you touched it, but if you continue to touch it and just stay there, you won't take any more damage until you separate from the enemy and then touch it again, which isn't what we want. So let's change this to on collision stay, or actually, no, actually that's fine. On collision stay, but now the problem is this function is called for every single frame in which we are touching the enemy, which isn't what we want either, because then we'll just die within like a second. That's not what we want. We want it to be on a set timer. So we'll make a new boolean. Public bool is being attacked. So we can't be attacked unless this boolean is equal to false. We can't be attacked unless we're not being attacked. If we are being attacked, we can't be being attacked more. If we're already being attacked, just let me show you. If collision.gameOut.attack is equal to enemy, then health equals health minus the damage. But we should also check if we're touching an enemy and is being attacked is equal to false. If we're not already being damaged in a damage cooldown, then we shouldn't be able to be damaged again until that cooldown ends. What is the cooldown? Well, I'll create it in just a moment. So, and this is equal to false, only then will we get damaged. But at the same time, if the stuff inside this function is run, then is being attacked should be set to true. So this can only happen once. On collision stay up, we touch the object, is being attacked, if that's equal to false, then set it to true and damage us. Now we can't be damaged anymore, because we've already been damaged. We got damaged, and now we can't be damaged anymore. But there needs to be a cooldown, an amount of time that once it passes, this value gets disabled again, and we can continue to be damaged again. In order to do that, we can use coroutines. Start coroutine. We can start a new coroutine, call this attack cooldown. Or actually, how about damage cooldown? I think that's a better name. Damage cooldown. Of course, this gives us an error. Damage cooldown is not defined. So let's define it as an I enumerator for quaternions. Damage cooldown. And now the error is player manager.damage cooldown. The error is not all cold paths return a value. What does that mean? Well, we need to put in our timer. Wait 4 seconds, and then the cooldown. So I'm just gonna set that to 1 for now. We wait 1 second, and then is being attacked should equal false. So now, after all of that, we touch the enemy, and while this value is equal to false, well, we haven't been attacked before, and then we get attacked, so now this should be set to true, so we can't be attacked anymore until this coroutine ends, until after 1 second. Then a damage opportunity opens up again, and we can be attacked again and again every single second if we're touching the enemy. So now, after that kind of small change, now everything should work. We have our health. If we run out of health, it restarts, and the enemies can only attack us so much per second, but they will continue to attack us if we're continuously touching them, which is what we wanted. Now all we need is enemy health itself. So when you stomp on an enemy, it doesn't destroy them outright. It modifies a value. Once that value reaches 0, then the enemy dies. That's the next thing we're going to add, and then finally we'll end the tutorial with making the enemies move randomly and giving them a bit of AI of sorts. So let's go back to Unity and test all this out. So immediately, is being attacked is set to false automatically. All booleans are false automatically. All bools are false automatically, unless you specifically set them to be on before the game starts, or something in code turns them on or off, or whatever. By default, they're all 0, which is false. And the Goomba enemy has all his stuff attached correctly. So now if we start the game, we should see our new designed system hopefully working. We touch it and, yep, we're continuously touching it, yet we're still taking damage in a nice set timer. Until we stomp it and kill it instantly. Which is kind of weird now that the player has health. The player has health, but the enemies don't. You know, it's not entirely what you want, so I'm going to disable the canvas for now. Go to the enemy. And instead of creating a UI raw image, because for the Goomba enemy's health bars, we want these to be shown on the screen relative to where the enemy is, not relative to the actual interface. So instead, I'll just create a new empty game object, call it Healthbar, and then I will give this a sprite renderer. Just make a nice box. Put it above the enemy. And then I'll make a nice blank bar as well. I'll copy it. And then the health bar is going to be red. Of course. Of course it'll be red. So now if we change this, they're overlaying a bit broken. So I'm going to set the order and layer for the health bar to be 1. And so now, if we change the scale of this, we can see stuff behind it, which is what we want. So now what we have to do is parent these correctly. Call it health bar, make a new empty game object, call it health bar, and then put the old health bar, rename it to HP, and put it in and parent it to the new health bar. So now if we change the scale of this new game object, then it will do exactly what we want, which looks a bit funky, but with actual sprites, it would look a lot better. So now we have this. It goes from 1, and then 1/2, and then all the way down to nothing. It works. And this blank bar is just a blank bar. It's just whatever. So now what we have to do, the only thing we have to do now, is recreate all that health bar code before enemies. Luckily now we know how to do it, so we can pretty much just copy a lot of it. So let's go back into the script, back into the enemy script specifically, and open it in Visual Studio, and get to work. Okay. So first, of course, we need to make some references. Public game object health bar, and a public float health, so that the enemy now has its own health values. And while we're at it, I'll add a public float max health as well. Let's go back into the player manager, and so now, and copy this. This is all fine. Yeah, just copy this code, the same code we just used, and paste that into the enemy. Not in the fixed update, not in the on trigger enter, not in any of this, but make a new void update and paste everything in here. Now immediately we get errors. Because scene manager is not defined, because up here it doesn't say using Unity Engine.scene management. But of course, if you actually look at this code, you can see what this code does is once health is less than or equal to 0, restart the scene. Obviously, if an enemy's health is at 0, it shouldn't restart the scene. That shouldn't happen no matter which way you slice it. So get rid of that, and then make sure that this is the case. Health equals 0, and then this .gameObject.setActiveFalse. So no, for enemies, death should work a bit differently. It should set health to 0, and then disable the game object outright. Disable the enemy when its health is 0. And that should work just fine. And then, of course, healthbar.transform.localscale equals blobbity blobbity. We already defined all that. So now the only last problem is the enemy doesn't lose health when we stomp on him, because we forgot about that. So let's fix that. We don't want it to kill the enemy instantly. We want to make its health equal to health minus 1. That should work much better. And there's no reason to do the coroutine stuff or anything like this. Having the players have to jump off the enemy and then jump back on in order to do more damage makes perfect sense. So we're just going to say health equals health minus 1. Or actually, what if we want the player to have a specified amount of damage? Then we can do collision.getComponent player manager dot damage. Of course, player manager does not have a definition for damage. We can fix that, of course, easily. We can just add public float damage. And now we can go back into Unity and test out these last few bits of code before we finally make the enemies have AI. Okay, we have to define a few things. Drag in the health bar for the health bar, which shouldn't be too difficult. Go to the Goomba enemy, go to his health bar, drag in health bar into health bar, if that makes sense. Make sure health and max health are set to 100. His damage is 10. If his damage is 10, then our damage should be 10 too. So, yeah, now we have health, he has health, we all have health, and we all have damage values. And so now, let me just enable the canvas. I forgot to re-enable that, actually. Hold on. Yeah, make sure to always re-enable things before you start the game. So now, the enemy has health, and if we stomp on him, if it touches us, we lose health, and if we stomp on it, then it loses health. And until it finally dies. Now, we have health, they have health, and everything's great. The only problem is the fact that these Goomba enemies literally are just Goombas. They move back and forth with no mind of their own. No AI, no nothing, no way to defend themselves, nothing, which is kind of boring. It's nice to have enemies like this just in the first place, but what if you wanted a different kind of enemy? Well, what we can do is we can go back into the enemy script, open it up in Visual Studio, and make a few changes. But one crucial step in this whole thing is let's make a new boolean called AI. So then we can have some enemies where AI is off and it just acts like a Goomba, and other enemies where AI is turned on in the inspector and it can use new code that we're about to write. So we can have our cake and eat it too. We can keep the Goomba enemies while also making some better enemies. But keep the Goomba enemies just in case we want to use that code for something else, why not? So let's do that. Fixed update. This can all stay because it's just moving back and forth. The wandering, okay, now that we have all of that set up, everything previously, all the health, now we can begin making the actual AI. And to start that, we need to do some randomization. For one thing, we need to put if statements everywhere. If AI, then put all of that in there. If not AI, then make a copy of it and leave this unchanged, because if AI is off, which it is by default, then it's just going to act like a Goomba, and it already does. This code already works that way. If AI is true, then movement wait time shouldn't just be movement wait time. Let's randomize it a bit for a nice wander phase. So let's plus, and then we can grab a random number from Unity random using this syntax, min max. This is how you generate random numbers. Random.range min max. It generates a random number between min and max. So what can these values be? Well, the movement wait times are measured in seconds. Normally like 1 second. So let's say 0.8, negative 0.8, and positive 0.8. 1, 1. Just have a bit random, and then it'll Okay, one problem with this is cannot convert from double to float because it thinks these are doubles when they're actually supposed to be floats. Random.range only works with floats, as you can see. Float min inclusive, float max inclusive. So we can just put some F's there, and then it actually functions properly. Just put some F's in here so Unity knows we're talking about a float in this case. So now, movement wait time, it will not wait whatever this is, it'll wait whatever this is. It'll add a nice random number, or subtract the random number, because it can go into the negatives. So the amount of time it waits will be slightly random, making for a nice wandering phase. But what if that's more than you want? What if that's not what you want? We now have an enemy that can wander around a bit more haphazardly, and it's kind of nice, you know, it moves a bit randomly in different ways. And that's cool and all, but what if you also want the enemy to follow you? How would you do that? Well, that's easier said than done, obviously, but it's definitely doable. We can add a new public boolean to check if the enemy is within a radius of the player. But to do that, we need to go back into Unity for a second. One great way to check if the player is in a radius of the enemy is with triggers. But we're already using triggers for the stomping mechanic. If you're touching the top of it, then the enemy gets hurt. So, and we can't really have two triggers and distinguish the two, at least if the two triggers are on the same object. So what we have to do is create a new empty game object inside the enemy and call this the player detector. Or actually, I'm just going to call it sight, because it's like seeing the player. And give this new sight game object a box collider 2D. Actually, no, I'm going to use circle collider because that's a bit less wonky. And so now we can have a nice 0.5 radius. Yeah, that works. This is a nice radius. If it's within this radius, then it can see the player. I'm going to set this to 0.25 because that actually works a bit better. How about 0.333? That looks good. 333. Whatever. That works fine. 1/3. Set this to his trigger, because this is supposed to be a trigger box. The player should not actually collide with this, but it can intersect it. And we can detect those intersections by making a new script inside of the sight game object and calling this enemy box. Or enemy, I'm just going to say enemy radius. Create a new script, create an add, and open it up in Visual Studio. Alright, let's get started with the actual player following, because so far we have it so the enemies can either wander in a fixed way or wander in a random way. If AI is on, then they wander in a random way. So I'm going to call this actual random wander. Add a little note, and then over here I'm going to call it fixed wander. Fixed wander because it's a fixed amount of time. They'll just move back and forth in a fixed way. While here, it's possible for them to go to the right longer than they went to the left and stuff like that, which is, you know, interesting. So now that that's set, I'm actually going to set this to 1.81 to make that even better. Now we need to make it so the enemies can follow you if you're close enough. How do we detect if they're close enough? Well, we just set up the enemy radius, so now we can go into the enemy radius class that we created, make a void on trigger stay 2D, and then check if the collision is the player. So check if collision.gameObject.tag is equal to player. If the player is intersecting with the enemy's radius handler, then we can set, then we can make sure that the main enemy behavior knows that the player is within range to follow. So we need to make a public enemy behavior, and set enemy behavior dot player in range. Like, let's say this is a boolean. Set player in range to true if the player is, well, in range, if he's intersecting the enemy's radius. And then we should probably duplicate this, add a new onTrigger exit 2D to set it to false. So once the player if the player reaches the radius and intersects with the radius, if he's inside the radius of the enemy, then player in range should be set to true. and if the player leaves the radius, player in range, the boolean, should be set to false. So now that that's set up, all we have left to do is define what player in range is in the enemy behavior. We'll define it as a boolean, and then we make the enemy behavior work differently depending on what that value is. So public bool player in range. So now all we have to do is make it so the enemy actually moves toward the player if the player is in range. Now, in order to do that, we could have the enemy look at the player and move towards her, but that doesn't work very well because then the enemy can move upward, which isn't what we want. So a better solution would be to add two if statements, player in range, and then duplicate this if statement. So now we have two if statements. Make one of them use the exclamation point, which means not, opposite, inverse. So now anything inside of this code will only run if player in range equals false. And then vice versa for the other if statement. This code will only run if player in range is equal to true. Because that's what this says, if player in range. If not player in range. So if player in range is equal to true, if player in range is not equal to true, because of the little not exclamation symbol. That's what dictates that. So now we can put code in here to make it do certain things. So if player is not in range, then we will take our random wander code and put it in here. If player is not in range, then wander. If player is in range, then do not wander. Instead, move towards the player. But how could we possibly do that? How do we know what a player is relative to the enemy? Here's how. First, we need to define what the player is. We need to be able to get data from the player by defining public game object player. But what if there's multiple players? Then we need to make multiple objects and it gets confusing. So let's do this instead. Public game object detected player. So now this game object will be whatever player is within our radius. Or whichever player we have detected within our radius. Of course, by default, this detected player is not going to be a game object. It's going to be empty. Like, literally, the value itself will not be anything. The detected player will equal null. It won't work. So we either have to define it in the inspector, which is not a good solution, or we can go into the enemy radius and make sure that if the player is within the radius, not only does player in range get set to true, but enemy behavior dot detected player gets set to the player that was actually detected. The game object gets set to the game object because the original game object is empty. So that we can save which player is within our radius. A little complicated, but it works. So now, if the player is within our range, this will be set to true, and this will be set to whatever player is within our range. And we can get data from the player that's within our range. So if player in range, then we can have a check, because our enemy can only move to the left or to the right. Knowing which way to go is hard. If the player is to the left of the enemy, then the enemy should move left to walk up to the player. But if the player is to the right of the enemy, then the enemy should move to the right. But how do we know which side the player is on? All we know is the player is within range. So here's a nice way to do that. We can take if this dot transform dot position minus detected player dot transform dot position, and then put this whole thing in parentheses because it's easier to understand. If this position minus player position is more than 0, or more than 0.5, I guess 0.25 here. If the enemy is close enough, it should just not move. I think that would make sense. So if it's more than 0.25, then, and if it's less than 2.5, if position minus player dot position is less than 2.5, then that means that less than negative 2.5, then that means that the enemy is to the left. of the player. And if this is the case, then enemy is to the right of the player. So now we have a nice detection system. Well, okay, actually I did miss one thing. We can't subtract two positions from each other. We can only subtract the components of those positions. So like .x, 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 position .x. So now, if this x minus the player's x is more than 0.25, then that means that this x is greater than this x. But if this x minus this x is less than negative 2.5, or sorry, 0.25, that means that the enemy is to the left of the player. So now we have a nice detection system. We could do this dot transform. We could do something like this. If this dot transform dot position dot x is less than detected player dot transform dot position dot x, we could do this, but I'm gonna not do that because having a minimum distance between the enemy and the player is very nice, because if the enemy is really, really close to the player, then there's no reason for it to be moving. Except I just realized that that actually won't work, because if the enemy is like away from the player and stops moving, then it won't be able to attack it. So actually, no, never mind. This dot transform dot position dot x is more than detected player dot transform dot position dot x, and then we can just invert this for the other bit. Sorry about that. So if this x is more than the player's x, that means we are to the right of it, and if it's less than the player's x, then we are to the left of it. That makes much more sense. It's easier to understand anyway, and it will work better. So now we know when we are to the left of the player or to the right of the player. The enemy knows if it's to the left or to the right of the player if the player is in range. Only if the player is in range, of course. And now everything can fall into place. All we have to do now is make it so if this is the case, then it only moves to the right, and if this is the case, then it only moves to the left. So right now, the way it currently stands, if either one of these is the case, and this is the case, then the enemy's just not going to move, because there's no code to make it move in this part of the code. So let's make that. This dot transform dot position. Actually, wait, we can copy this code from somewhere else. If I just scroll up here, where is it down here? Wait, where is it? Here it is, here it is. If move direction equals false, then, yeah, if move direction is equal to 0, or false or whatever, then move to the left, and if move direction is true, then move to the right. So all we actually have to do is just make move direction correspond to this. If it's to the right, so then make this equal to false, so we move to the left, if move direction equals true. And now, we should be able to test this in Unity. Let's see if our brand new system works properly. As long as enemy behavior is assigned, of course, then we can try this out and see what happens. Of course, by default, the enemy is moving around in a haphazard way, which is exactly what we want. As you can see, they're floating, but we can fix that in just a bit. But if I get too close to the enemy, then he'll start moving and he'll chase me until I can get away from him. But I can't, of course, until I do that, and then he gets confused and gets stuck going off into oblivion for some reason. That's a little weird. Okay, it seems as if he got stuck. Let's review our code and see what the problem is. Oh, okay, I see the problem. If player is not in range, then random wanderer. Yeah, sorry. The start priority and wait to move shouldn't be in here. It should be all the way out here. It should always happen no matter what we're doing. And this shouldn't be here either. Now it should work properly. Or at least better. Now we can test it. While we're at it, let's fix the other issue where the enemy can float. It moves over here and it just starts to float. Let's fix that real quick by giving this enemy a rigid body 2D. There we go. Now we can test the game and see what happens. And now the enemy is up. I didn't foresee that happening. Nothing we can't fix. We can go into our rigid body 2D settings and freeze rotation in constraints. That will make it run much better. Well, it won't, I don't think it'll mess with that much performance-wise, but the enemy will work much better and will end up killing itself randomly because it's still kind of brainless, but at least it has a bit more of a brain now. So now if we make a bunch of enemies, we can see them all interact. Well, not interact, but do this. Very, very dumb enemies, but they will follow the player now, and if we round out their hitbox, then they won't get stuck in the weird loop that they seem to be getting stuck in. Or get stuck on these ledges, actually. Here, I can actually show what it's like if you round out their edges, instead of having a nice box. Because it makes perfect sense why that doesn't work. So get rid of that, and then replace it with a circle collider 2D. 0.8, 0.9, 0.11, wait. Okay, we got 0.10, 0.1, 0.05, 06, 07. That looks a bit better, a bit more promising. Now if we test this, we walk up to the enemy, and it falls into oblivion, of course. Okay, you know what? I'm going to change one slight thing about the map. The holes are fun, but the enemies don't like it. Now if we go back in, we should see them wander back and forth, and then be able to follow us a lot better than they did before. They should probably not have the same speed as the player, of course, but we can fix that by changing the enemy move value to be less than the player, and then running the game again and seeing what happens. Yeah, there you go. Now, one thing you might have noticed is the enemy took damage when we were within its sight radius. That's because the addition of new triggers can mess stuff up like that. But there's a decent solution. We have to go through the code and change a few things, but it's no big deal. First of all, we add a reference, public game object enemy body, and then we make sure that this enemy body is actually what we're targeting when we try and set like stuff to false. If we want to turn off the enemy, then we turn enemy body to false instead of this object itself. And you'll see why in just a moment. Set this to enemy body. Scroll down here. See this set this to enemy body. Set this to enemy body. Set it all to enemy body. Go down here. Set this to enemy body. Set this to enemy body. I'm just going to control C this actually. Set it all to the enemy body, to make sure that the script runs the same no matter what object the script itself is actually on. As long as everything's assigned correctly, the script should work the same in all environments, because I'm about to change where the script is to make the collisions work a bit better. Now that that's done, we can go back into Unity and make one slight tweak. Now for the final couple of steps. This is what manages the stomping. So what we're going to do is we're going to create a new object next to site. We're going to duplicate site and call it enemy behavior. Remove the enemy radius. Remove the circle collider. So now we have an empty object called enemy behavior. And we're going to drag the enemy script onto the enemy behavior object. And we're also going to drag the stomp trigger onto the enemy behavior object. Or, well, actually, we're going to have to copy component and then go in here and then paste component as new. But it still works. Then we can get rid of this mess. Get rid of that. So now the Goomba enemy object has a rigid body 2D, a sprite renderer, and a circle collider that is just a collider for the enemy itself. And then the site bubble manages sites, and we need to reassign enemy behavior to the enemy behavior right here. And then enemy behavior exclusively manages the behavior and only the behavior and stomping. So now we just need to drag an enemy body for the enemy script. See, before, if the enemy were to die, then enemy behavior would now just disable itself. But the enemy itself would actually stay. Only the behavior would turn off. But now, that's fixed. Enemy body would be turned off, which is the whole enemy. So it'll do the exact same thing as before, but better. Because now, the triggers are all separated. So now, as you can see, it's not taking damage for no reason. It'll only take damage if and only if we touch it. Only if we touch it will it finally take damage and die. One last fix. Having start coroutine here skips all of this before it starts the next coroutine, meaning this script, this coroutine will duplicate itself a billion times per second, which isn't what we want. So get rid of start coroutine and put it here, and then put it also here, and then finally put it also here. That should work much better, I believe. Let me just look through this real quick. Yep. Actually, I'm going to remove these. Place this here. That should give the exact same results. Actually. Yep. There. Now go back into Unity and do a final test. Two more last minute things to change. Make sure this says get component in children in the player manager. Because if it doesn't, then it won't be able to find enemy, because enemy is no longer on the enemy itself, it's on a child of the enemy parent. That's called enemy behavior, as we did earlier. So change that to get component in children, and then one final change, we go back to the enemy script. We scroll down here until we get to this portion, and we make extra sure to add a nice wait for seconds bit. That waits 1 second before it actually does anything. Just to add some nice delays, or else things can lag out very quickly. And now with that done, we can finally go back to Unity and test. Let's start the game and test out our new enemies. It's following, and if we get close enough again, it should begin to follow once again. And if we go around here, get near it, then it starts to follow again. Just go up here, starts to follow. It's a little bit delayed, but it works. And if you want to make it different, you can change the value we just set to make it more responsive. But the more responsive it is, the worse it is on performance, so you gotta be careful there. But we can stomp it, and if you think we're stomping it too slowly and we're not doing enough damage, then you can increase the damage of the player, or you can increase the health of the enemy, or decrease the health of the enemy. So now we have health, we have enemies that move back and forth, we have enemies that could also be Goombas, we have enemies that can follow the player, and we have all this stuff. And that is how you make enemies, or at least one way to make enemies, in your 2D platformer.